All right. So let us start our class today. Okay. So dimensions. In a lecture, we have seen that what is dimension. We use it to determine the derived quantity in terms of basic quantity. Okay, the combinations of basic. So how are we going to get a unit for a derived quantity? We use dimensions. So the first thing that we're going to do today is to use dimensions to derive the quantity for various derived quantity. Okay, before we proceed to the next part. So first one, velocity. Now, in order to find the unit for derived quantity, the first thing that we need to know is the unit. Okay, you need to know the unit for each of these derived quantity before you derive its unit. So velocity is equals to change in the displacement. Okay, change of displacement over change of time. Now usually we just write it in terms of a symbol. Now if you write it without square bracket, it simply means that you are going to calculate the values of the velocity of something. Now when you add in a square bracket like shown in the examples here, then you're telling the reader now you don't want to calculate the value. What you want to do is to find its dimensions, to use its dimensions to determine the unit. And the unit determines by using this method, it's always in the forms of SI unit. So SI unit, what does it mean by SI unit? SI unit is a international recognized, okay, internationally recognized unit. So once you write it in the forms of SI unit, so the scientists from all the other country they know what does it mean. Okay, it's unlike in some rural area where they are still using the length of the palm as one of the measuring apparatus. They are still using the length of the arm, the length of the foot, and so on. Okay, so all those they are not being recognized internationally. So that one you cannot use it if you are going to publish your report, publish your paper, and so on. So that's why we need SI unit, and SI unit is very important, especially in science, so that the scientists from all the other country they know what does it mean. Okay, which quantity to use, how do you obtain this value, this theory, and so on. So in this chapter, we're going to focus on how to get SI unit. And there are two types of SI unit. First one is the SI unit in terms of a mass, a meter, and then a length in meter, time in a second, and then mass in kg. Okay, the most often seen one, length in terms of meter, and then mass in terms of a kg. This is a SI unit, not gram, yeah. And then time in terms of a second. Of course, there are the other four, okay, that we have seen in a lecture. So we have another four, which is electric current, temperature, amount of substance, and luminous intensity. Okay, but today we're just going to focus on the first three. Okay, the first three were mass, length, and time in our examples here. So SI unit, when it comes to these three quantity, meter, kg, and a second, this one we call it base SI unit. Okay, and there's another one SI unit in which we call it special SI unit. For example, when it comes to force, work, and power. Force, most of the time we use a Newton. Work, we use joules. Okay, and then power, we use a watt. So these three, we call it special SI unit. It is SI unit, but it is not in the form of base quantity, base unit. Okay, this is what we call special SI unit. So it is SI unit, nothing wrong, but not base. So what we are going to do, we are going to find the base SI unit today. And it is very important because this question, it likes to come out in your exam. Okay, so when it comes out in the exam, students don't know how to determine it or what does it mean by base SI unit. So base means you are going to write it in the form of M, S, kg, and so on. Okay, not the one in Newton, in joules, in watt, and the special one. So first one, velocity. Velocity is a change of displacement over change of time. So as you can see here now, displacement is a types of a length. Because you measure with meter ruler, you measure the length of the path travel, of the distance between 2 points. So this one, when you're going to change it into dimensions, we use symbol L. Okay, L represents a dimension for length. Okay, that is related to length. And then time, capital letter T. Okay, that's why when you simplified it, you have LT -1. So from LT negative 1, L represent length and then T represent time. Therefore, you just change it into meter per second. L you change it to M, and then a T you change it to S. And that is how we obtain SI unit for every derived quantity. Next one is the volume. Okay, so volume we know is the wave times the length times height. And all three of them, they are related to length. You measure it by using length. Okay, you measure the lengths and then you times them to obtain the volume. Therefore, when it comes to a dimensional analysis, okay, so you have a length, length. Therefore, it's equals to L3. So L3, L is in terms of length. SI unit for length is meter cube. Okay, so M3. Accelerations. Now, acceleration is V over T. Okay, change of this velocity over change of time. Now, change of velocity in our examples here, we know V is equals to LT negative 1. Why? Based on the first example. Okay, first example, we obtain V equals to LT negative 1. But in exam, sometimes you don't have it. So sometimes you might need to do an extra step to find out the dimension for velocity first before you derive the dimensions for acceleration. Okay, so this one we can do a shortcut because we have the answer from first example. So A equals to del V over del T, which is equals to LT negative 1 divided by T. So LT negative 1 divided by T, you obtain LT negative 2. Therefore, the unit is MS negative 2. Right? So what I want you guys to do now is something very simple. I will give you the formula and then I want you to try to find out what is the unit in terms of a SI unit, okay, in terms of base unit. So density is M over V, capital letter V, mass over volume. Momentum is equals to mv, mass times velocity. Okay, so density is capital letter V, which represent volume. Momentum is a small letter v, which represent velocity. Force is equals to ma. And then works is, we are going to use now, works got several equation. So in this example, I wanted to use Fs. Okay, and then power. Powers also got a few equations. Now in these examples, I wanted to use a W over T. Okay, so I gave you this 5 formula. I want you to try to identify its unit in terms of a base base unit. All right. So I give you 5 minutes. Once you obtain the answer, you write it down in the chat box. Okay, in the message box. What is the unit for density, unit for momentum, unit for force, unit for work, and a unit for power? All 5 of them. 5 minutes, start from now. Okay, so faster. I want to see your answer. So you guys just pick one and answer. I told you guys to write down all five, right? You see, Irfan is not listening just now. I say I don't want special SI unit. I want it in terms of base unit. Okay, so don't give me Newton, Joule, and Watt. I want it in terms of a kg, m, and s. All right, so I give you guys one more minute to try it. All right, now let's see whether you got a correct answer or not. Okay, let's try it together. Now, density is equals to m over v. Now, based on the ways you guys write down your answer, I think quite a lot of you are going to get a 0 marks in your exam. Okay, because you put the stroke palang at the wrong place. Okay, so now let's see how are we going to solve it. So density is equals to m over v. Okay, so density, which is rho, so I'm going to put a square bracket here, which is equals to m over v. Now mass, m is mass. Okay, m is mass. Therefore, when you want to change it into uh, dimensions, then it's going to become capital letter M over V. Now, V, based on the previous questions, we have the dimension in L cube. So L cube. So which is equals to ML negative 3. Okay, ML negative 3. So from a fractions denominator, you want to move it up. So it becomes negative 3. So M in terms of a kg, L is meter. So kg, M negative 3. So that is the answer for density. Okay, first question. And then next, we are going to look at the second questions. So second questions, we have momentum. Okay, second questions, we have a momentum. So momentum, the symbol for momentum is P. So P equals to mv. Okay, so P equals to mv. M again is mass. So m, v is a velocity. So velocity, we've seen it before, is L T negative 1. Right? So this one, when you want to write it in a unit, it becomes kg ms negative 1. All right, kgms negative 1. Now, if you notice the way some of you wrote it, okay, you give me equation in terms of kg stroke ms negative 1. This is wrong. Why? Because this one, it simply means, wait, now let me check again your answer. You give me kg stroke, ms. Okay, you give me kg stroke ms without the negative 1. So now what does it mean when you write it in this form? When you write it as a kg stroke ms, it means this unit is kg m negative 1 as negative 1. You're putting the stroke at the wrong place. All right. So if you want to write a stroke in a unit, then this one, it should be kg m stroke s. All right. So this is wrong. So the correct one should be kgms negative 1. Alright, so ada beberapa orang bagi saya bentuk palang. Okay, palang bukan bermaksud salah, dia betul juga, tapi palang kena di tempat yang betul. Alright, tadi saya nampak ada 3 atau 4 orang bagi saya palang di tempat yang salah. Alright, next one. Next one, okay, I just mentioned it just now. I don't want special SI unit. I don't want Newton, I don't want Joule, I don't want Watt. Okay, what I want is in terms of kg, m, and s. So let's see how are we going to derive it. So force equals to m a, which is equals to, now m again is mass, so you put m here. A, according to derivations in the previous questions, we have LT negative 2. So this is the dimension for force. Okay, the dimensions of force. So when you change it into SI unit, it is kg m as negative 2. Okay, kg m as negative 2. So this is the unit in terms of base unit. All right, SI unit in terms of base unit. So make sure you know how to find the base unit, because question like to ask these questions. Okay, exam they like to ask this question. So work is W. So W equals to Fs. Okay, so force, according to the previous questions, we have a mLT negative 2 times, now what is S? S is the displacement. Okay, S is displacement. So displacement is a form of length. So times L. Okay, times L. Therefore, the answer is ml square t negative 2. So the unit is kg m square s negative 2. Power equals to W over T. So we have P equals to W over T. So W, according to the previous questions, we have ml square T negative 2 over, now this is time is capital letter T. Okay, which is then equals to ml square T negative 3. Why negative 3? Because T negative 2 divided by T equals to T negative 2 minus 1, which is T negative 3. So we have kg m square s negative 3. Okay, so for those who got all correct, congratulations, means that you understand how to do the derivation. Okay, so for those who got it wrong, I give you 1 minute to write down the correct answer. Okay, it is very important because these types of questions, when it comes out in the exam, it worth 2 marks. 1 marks coming from a dimension. Okay, if you got the dimensions correct, then 1 mark. And then the second sub question, usually it will ask you to transform the dimensions into base SI unit. Okay, so in that case, once you write down kg m negative 3, another 1 mark. So 1 question, 1 derivation question, it worth 2 marks in your final exam. Okay, and sometimes these types of questions, it will comes out in UPS as well. So UPS, 1 questions, 1 mark. So make sure you know how to do it. Right, so 1 minute for you to write it down. Then we are going to proceed to something new. All right, next. So if you guys got any questions, make sure to ask, yeah, because we are going to finish chapter 1 today, and then you will have the competitions this weekend. All right, try to score well in the competitions so that you got free data. Okay, the price is a free data, so you can use it for online class. You don't have to keep top up your own data. All right, now let's look at LO 1.1c. So verify the homogeneity of equations using dimensional analysis. Just now we use dimensional analysis to derive unique. Okay, so dimension is a form of unique where we use to derive it's a form of a technique where we use to derive unique. So when it comes to a dimension analysis, it is another functions of dimension, okay, which we use to check the mathematical relation for the consistency of their dimension based on principle of homogeneity. Now, what does it mean by homogeneity? So principle of homogeneity state that all terms appearing on both sides of an equation, they must have same dimension. Okay, so it means dimension, okay, dimension on the left hand side is equals to the dimension on the right hand side. Okay, so for example, if you're given an equation, for example, the equation is A plus B equals to C plus D. So you check the dimensions on both sides. Okay, you check the dimensions on the left hand side, and then you check the dimensions on the right hand side. See whether they are equals or not. If they are equal, then these equations might be correct. Okay, not necessarily correct, but might be correct. There's a chances that you got the correct equations. Okay, the equations, the relationship is correct. But if they are not equal, then it means this equation is definitely wrong. So you cannot use these equations in your calculations. So the use of dimensional analysis, the first thing to determine whether a physical equation is correct or not dimensionally. Okay, so dimensionally correct or not. So the words dimensionally is very important. Okay, dimensionally correct, dimensionally correct, it doesn't mean that the equation is correct. Okay, it doesn't mean that the equation is correct. It just means that there's a chances that the equation is correct. But if it is dimensionally incorrect, then the equation is definitely wrong. All right, so if you got a case where it is dimensionally incorrect, then it is equals to equation is incorrect. So the terms dimensionally is very important in your conclusion, in your answer. If the question asks you to check whether the equation is homogeneous or not, then this is the terms that you need to mention dimensionally. You mention about its dimension. You don't mention that the equation is wrong. The equation is correct. All right. You have to mention it is dimensionally correct. It is dimensionally incorrect. So that is how you answer the question, and that is our main focus today. Okay, we are going to check the dimension for various equation. So this would be our main focus today. So determines the units of the physical quantity. We just tried it. So this is done. And then to derive and construct physical equation. So sometimes scientists, they carry out a various experiment. They check the relationship between few variables. Based on the relationship of those variables, they then construct a new equation, okay, that is going to come out in your physics textbook. So so this one, okay, this one they use it to construct equation based on experiment, okay, based on the situations given. So it was one in your syllabus, but now it's no longer in your syllabus, so we are not going to look at it. Okay, this one is the objective, but it is no longer in your syllabus. So you just have to know the existence of this function. You don't have to know how to construct equation based on a given situation. All right. So next we are going to look at the first objective. Okay, we are going to use it to determine whether an equation is a dimensionally correct or not. So dimensions cannot be added or subtracted, but it can be, okay, you can use it in a multiplications and division. All right, so for example, just now, okay, the things that we did just now, all this involve a multiplications and division. If you look at this one, okay, this is multiplication, this is division. So you can use it in a division or multiplication, but then you cannot subtract it. Why subtractions and additions, they are not allowed? Okay, the idea, the concept is very simple. Now, let's say if you have 1 cm plus 1 cm, then the final answer is definitely in terms of cm. So the dimension is still here. Okay, you cannot subtract the dimension. You cannot say, oh, now I have cm, cm minus cm equals to no cm. No. All right, that's why you say you cannot add it or subtract it. So it won't be like cm plus cm equals to cm2. No. Okay, it's still just 1 cm here. So you still have a dimension L, so dimension L. Therefore, you cannot add the dimension. It cannot becomes 2L. So that is wrong. Okay, that is wrong. So dimension cannot be added or subtracted. The validity of an equation cannot be determined by dimensional analysis, but only obtained from a theory or determined by an experiment. Okay, that's why I say if you want to construct an equation, then you need to do an experiment. But this is no longer in our syllabus, so we are not going to look at it. Okay, next, before we proceed to a hands-on example exercise, there are a few things that you need to take notes. Dimensions of a dimensionless constant. Now, dimensionless constant means that in equation, sometimes you got just a value. Value, of course, it has no unit, no dimension. Okay, so in that case, we say the dimension of those constant, it is equals to 1. Okay, so if you have a constant value 2 in the equation, when you want to do dimensional analysis, you assume it is equals to 1. Okay, so other than L, M, T, sometimes we use 1. Okay, why? Because they are dimensionless. Okay, dimensionless. Dimensionless means no unit. Okay, no unit. So refractive index is just a value, therefore it is equals to 1. Angle, again, is equals to 1 because it has no dimension. Ratio of two quantities also equals to 1 because their dimensions cancel out with each other. Okay, now there are a few things that I want you to take notes as well. Sometimes you'll be given pi. Pi is just a value. So the dimensions for pi, again, it is also equals to 1. Okay, so another common sense dimensionless scenario is a tangent theta, cos theta, sine theta. So tangent theta, sine theta, cos theta, they have no unit, therefore it's also equals to 1. All right. So another possible situation is the exponential value or ln. Okay, your ln, log, they are all dimensionless. For example, you have ln 5. Ln 5 is also equals to 1. Exponent 10, it is also equals to 1 because all these, they are dimensionless. They have no unit. All right, so even though they have a ln, exponential, tangent, and so on, their dimension is always equals to 1. Okay, now the last one, okay, this one, it tells you why can't you use dimensional analysis to determine whether an equation is correct or not. First, because it is unable to determine if there's any incorrect coefficient. For example, now you have an equation a plus 2b equals to c plus d. When you check the dimension would be same as a plus 3b equals to c plus d. A plus 4b equals to C plus D, they will also have the same dimension. Why? Because all these numbers, when you do dimensional analysis, they are all equals to 1. Okay, so you won't be able to tell whether they are correct or not. So all you know is that, okay, now they are dimensionally correct, but whether they are in correct equations or not, you don't know. Unless you conduct the experiment, okay, unless you use experiment to find out what is a correct coefficient in the equation. All right, and then the missing terms or an extra term in any physical equation. Okay, sometimes there might be another terms that come with the same dimension. For example, now there's an E here. So E has the same dimension as a D and C. But when you do dimensional analysis, you don't know whether this E should exist or not. Okay, so for example, okay, now this C is in terms of cm, 2 cm plus 3 cm, and then plus 4 cm, you say. Now, sometimes equations may be just correct until C plus D. If you add in E, then this become incorrect equation. But you cannot tell from the dimension, okay, because the dimension is still cm. When you add them all up, add them together, it is still in terms of cm. So you can tell from the dimension, all right? And another reason, so this is the first reason, this is the second reason, you can't tell whether there's a missing term or extra term. And then the third reason is because of the sign convention, okay, of the sign convention. So plus or minus, it won't affect your dimension as well, okay, or the plus sign here. If you change it into minus sign, you're still going to get the same dimension, regardless of the sign convention. So sign convention is another reason why we won't be able to determine if an equation is correct or not based on dimensional analysis. Okay, so now let's look at an example. So I will use my own notes quite often. Okay, actually I prefer to use my own notes rather than your handout. Okay, but since they want to standardize it, so we have to use your handout. I'm going to explain everything based on your handout. But sometimes I will use my own notes as well. Okay, because there are some things that I have it in my notes, but not in your notes. So now let's look at the example. Okay, now this example, if you notice, I put a bracket in dimension. Okay, that is because I refers to a university books. But when it comes to pre-U level, somehow they put the bracket in equation. Okay, so we follow your standard, your level. So, wait, hang. All right. So we are going to follow the rules in your matriculation syllabus. We are going to put a bracket in a V, U, and AT instead of the dimension, all right? So this one, just an example, you don't follow the bracket here. Okay, this bracket is for the university level. In your level, we put a bracket in the equations. So given V equals to U plus AT, check if it's dimensionally homogeneous. So dimensionally, it asks you to check the dimension. It won't ask you to check if the equation is correct. All right, so you look at this, dimensionally homogeneous. So you have V equals to U plus AT. How are you going to check? So again, you don't use this symbol, okay? The symbol that I put in the example, question mark equal. This one, it means you are unsure whether left-hand side is equals to right-hand side. In your syllabus, they don't use this equation, okay? So what are you going to do? You're going to split it into left-hand side and right-hand side. Left-hand side, we have V, okay? So you put a bracket here. According to your syllabus, you put a bracket in a variable. So V, the dimension is LT negative 1. So this is for left-hand side. Now we are going to do it for right-hand side. Okay, for right-hand side. So right-hand side, we have a U plus. So even the half, you have to put it in a square bracket. Okay, you have to put in a square bracket. AT square. So this is right-hand side. Okay, this is right-hand side. So left-hand side, you do it first. You do it separately. You don't do it in the equation form. You do it separately. You do it for left-hand side, and then you solve it for the right-hand side. So right hand side now, okay, the dimension for u is also velocity, therefore LT minus 1. Okay, and then plus, so this half is equals to 1, and then A, okay, what do we have as A? LT negative 2, and then T squared is a T square here. Right, now let's simplify it. So if you simplify it, you're going to get LT negative 1 plus, okay, L, okay, because T squared times T negative 2 is equals to T0. So T0 equals to 1. Okay, so T negative 2 times T2 equals to T negative 2 plus 2 equals to T0 equals to 1. Okay, so for those of you who don't know where is the T, where is it gone? So this is the reason, okay, why T is no longer in our equation. So now if you look at the right hand side, what happened here? Okay, now you have one LT negative 1 and another one is L. They are not the same. And when you compare to left hand side, they are also not equal. Left hand side, you have only LT negative 1. Right hand side, you have LT negative 1 plus L. So in this case, you can make a conclusions where left hand side is not equals to right hand side. Okay, therefore you can now come to the conclusions that they are dimensionally not homogeneous. Okay, dimensionally not homogeneous. So it means now the left hand side and the right hand side, they are not equal, so the equation is incorrect. So this one you can mention equation is incorrect, okay, because they are not equal. When left hand side is not equal to right hand side, it is definitely an incorrect equation. Okay, now let's go back to the notes here. So dimensions cancel just like algebraic quantity. Okay, so this one you do it like subtractions or multiplications, and a numerical factor like half here. So it do not affect the dimensional check. So the value half, you don't have to include it. If you want to put it, you just put it as 1. All right. So the dimensions on the left hand side does not match the one on the right. Therefore, the equation is incorrect because they are dimensionally not homogeneous. Okay, so that is how you check the equation. Now let's look at the second example. Second example, it shows you why, even if the question is a dimensionally homogeneous, but the equation is still wrong. Okay, so now given S equals to UT minus 1 over 2AT squared, check if it is dimensionally homogeneous. So now let's try it. Left hand side, what do I have? I have S, which is displacement. So dimension for displacement is L. Right hand side, now I'm going to show you second method. Okay, second method, sometimes you can do it separately. Okay, you don't have to do both quantity at once. Okay, you can do UT and then half AT squared. All right, so if there's a plus minus sign, actually you can split into two parts. So UT, okay, we're going to solve the UT part first, which is equals to, okay, now U is velocity, LT negative 1, T is time. Therefore, the dimension for this part UT is L. All right, and then the second part in the equations is 1 over 2 AT squared. So 1 over 2 AT squared is then equals to 1, and then A is a LT negative 2, and then this T again is a T squared. All right, so eventually you're going to get L. So you split it, okay? You don't have to combine them together. You don't have to combine UT minus half AT squared into 1. You can split the UT as one part, half AT squared as one part. And then what are you going to do next? You're going to check the dimension for all three of them. Okay, so for part S, left-hand side, you have L. UT, you're going to get L as well. Half AT squared, you get L. Therefore, we say this one, the left-hand side is equals to right-hand side. Okay, so they are dimensionally homogeneous. Okay, homogeneous. So let's go back to the questions again. Now it says here, note, addition and subtraction won't change the dimension. Okay, it can only be done if both quantity have the same dimension. Now, what does it mean? So it means this part. So if you look at the question, I have L minus L and the dimension is still equals to L. Why? Like I told you just now, 1 cm minus 1 cm, the answer is still in terms of cm, 0 cm. So the dimension is still the same, cm, cm, cm. Okay, so it won't change the dimension, additions or subtraction. All right, it still have the same unit. And it can only be done, you can only subtract them if both quantity have same dimension. Okay, you cannot use cm minus kg, cannot. All right, so you have to make sure they have same dimensions before you do the subtractions or addition. Otherwise, it would be wrong. So the dimensions on the left, okay, the dimensions on the left is equals sign matches on the right. So the relationship is dimensionally correct. However, okay, however, this equation actually is incorrect. Why? The correct equation should be S equals to UT plus half AT squared. The sign is wrong, but you can tell based on the dimensional analysis. Okay, the dimensional analysis won't tell you whether this sign, the plus or the minus sign, is correct or not. It can only tell you the dimension is equals or not, is homogeneous or not. Okay, so this is an example why dimensional analysis can tell whether an equation is correct. Although the equation is dimensionally correct, but this equation in fact is incorrect due to incorrect mathematics operation, okay, which is the sign convention. So the correct equation should be plus. But in your exam, you still have to answer it is dimensionally homogeneous or dimensionally correct. Okay, correct in terms of dimension, just that it is incorrect in terms of operation. All right. So this is a two example that shows you how to do a dimensional checking. So what I want you guys to do now, okay, I want you to try these three questions. Okay, actually the first two. The last one I will discuss with you because the last one is slightly more complicated. So what I want you to do now, I give you 10 minutes to solve questions A and questions B. Do it yourself. Don't refer to the one that I showed you just now. You tried it without looking at the notes. See whether you understand or not. Okay, because dimensional analysis is a very popular questions in your final exam. All right, so start now. You have 10 minutes to do both questions. right, now let us finish these three questions. Now I'm going to let you guys go. Okay, I might finish a bit late because I tried to finish chapter 1 today. So S equals to ut plus half at square. Wait, yeah. So now we're going to do it in left hand side and right hand side. Okay, we need to split it into left hand side and right hand side. You cannot combine them. So it's a very common sense mistake in the exam where students they straight away do a derivation from this equation. That is a very bad thing to do in the exam because you haven't checked. You don't know whether they are equals or not. Okay, so what students they always did, they start from these equations and then at the end, the last step, they put an unequal sign. So in terms of a mathematical idea, it's wrong. Okay, so you cannot start from this equation. You need or you must split it into left hand side or right hand side. Okay, so left hand side you have S, which is equals to L. Okay, and then right hand side. Right hand side you have a ut plus 1 over 2 at square. So u t plus 1 over 2 a t squared. Okay, which is then equals to lt negative 1 times with t plus 1 and then lt negative 2 times t2. So eventually you're going to get L plus L, which is equals to L. So when you compare the dimensions for both right and left hand side is L, right hand side is also L. So then you can make a conclusion. Okay, left hand side is equals to right hand side. Make sure to answer the question. So question asks you to determine whether they are dimensionally correct. So yes, okay, the equation is dimensionally correct. So that is how you answer the questions. So these questions usually it worth 2 to 3 marks in your final exam. Okay, do the analysis checking. All right, now let's try questions 2. Okay, questions 2, again, we are going to start from the left-hand side. So left-hand side, we have V, which the dimension is LT negative 1. Right-hand side, you have a U minus 2GS, which is equals to LT negative 1 minus 1 and then G. Now, G is a form of acceleration. Okay, acceleration is due to gravity. Therefore, the dimension is LT negative 2, same as acceleration. And then your S is a length displacement, so it's L. Okay, it's L. So you have a LT negative 1 minus, okay, now this one you have a L and then you have L, so it becomes L square T minus 2. So obviously, the left hand side and the right hand side, they are unequal. So in this case, the conclusions would be left hand side is not the same as right hand side. So the equation, okay, the equation is dimensionally incorrect. Okay, dimensionally incorrect. So that is how you answer questions 2, right? So before we proceed to questions 3, I give you 1 minute to write it down, and then we are going to do questions 3 together. So if you have any questions, you may ask now. Okay, so last question. Now let's look at it together. These questions, usually students won't be able to answer it. Why? Because of this square root. So what are you going to do with this square root? Now it's very simple. Let's begin with left hand side and right hand side again. So left hand side we have just t. T is period. Period is the form of time, the time taken to complete one oscillation. So the dimension is a t, time, okay? So right hand side. So right hand side is a crucial part. So square bracket, you put a 2 pi here. Okay, because 2 pi, both of them, they are dimensionless quantity. So you can put them together. And then square bracket for square root L over G. Now let's think, how are we going to simplify it? So we still have a 2 pi here. Square root. Square root, in terms of the law of indices, it is equals to the power of half. So it is equals to L 1 over 2 divided by G 1 over 2. Okay, it is then equals to 2 pi bracket. Okay, now I want to move this denominator. Okay, I want to make it, I want to bring it up. So it becomes L 1 over 2 G negative 1 over 2. Okay, if you want to move the denominator up, then you add a negative sign here. Okay, you add the negative sign. So you have a negative 1 over 2. And next, okay, now that I've reached this step, I can then proceed to a dimensional analysis. So 2 pi dimension is equal to 1. Okay, so L, what happens to L? L is a length. So I have a L 1 over 2 here. Okay, G is a gravitational accelerations. Okay, accelerations due to gravity. So we have a L T negative 2, and then with a power of negative 1 over 2. So it is equals to L 1 over 2, and then times L negative 1 over 2, and a T becomes a 1, right? Which is then equals to T. Okay, which is equals to T, because L half times L negative half. Okay, L over 2 times L negative 1 over 2, it is equals to L 1 over 2 minus 1 over 2, L 0, which is then equals to 1. Okay, which is then equals to 1. Therefore, by looking at these solutions, now the left hand side is equals to T, the right hand side is also equals to T. Okay, so the conclusion is left hand side is equals to right hand side. So the equation is dimensionally homogeneous. Okay, dimensionally homogeneous. So that is how you solve it. Okay, that is how you solve the questions. So we are done. Okay, that marks the end of chapter 1. So do you have any questions? Class?
No, madam.
No, madam.
No, very good. All right, so if no questions, okay, and you already write out the answer, then you may leave the class. That's all for today. I'll see you all again on a Thursday.
Thank you, madam.
Thank you,
Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.